So welcome to the examples for session 2.3. We're going to go ahead and do number 18. And number 18 is asking us to plot each pair of points to determine the slope of the line containing them and then graph the line. So the points that they give us is 4, 2 and 3, 4. And so for the first point in point A, you can see here that point A is the ordered pair 4, 2. So x is equal to 4 and the y is equal to 2. For point B, here on the screen, the point is 3, 4, so my x is 3 and my y is 4. And so we plotted each point, we're going to determine the slope. So the slope for a line is the rise over the run. And so if I'm going to go from point A to B, you notice that what I'm going to do is go from 2 up to 4, and so that's a difference of 2, so that's a plus 2. Then I'm going to go from 4 on the x to 3 on the y, to 3 on the x, and that's a minus 1. And so it appears that the slope for this particular line is going to be negative 2. Let me go ahead and plot these. Oops, that's not what I wanted to do. There you go. And so here's the line that we have. And again, if you think about the slope being rise over the run, it's going to be the change in y, which is from 4 to 2, over the change in x, which is 3 to 4. And so it doesn't really matter if you use point A or point B, we'll still get the same value. So graphically, that's what this, that's how this would be done. Now, going here algebraically, I'm going to go ahead and find the slope. First thing I'm going to do is I'm going to go ahead and label the points x1, y1, x2, y2. Then I'm going to go ahead and plug these in. So my y2 is 4, my y1 is 2, my x2 is 3, and my x1 is 4, similar to what we did on the other screen. So 4 minus 2 is 2, and then 3 minus 4 is negative 1, and our slope ends up being negative 2. So that's how you do that algebraically and also just graphically, so we can see both methods. For question number 26, it says graph the line that contains the point P and has slope M. And the problems, and then it's telling us find the point slope form of the equation. And so for number 1 here, you can see that I have the point slope, and then number 2, I have the slope intercept form. And so what we're going to do for number 26 is we're going to go back here graphically so we can see it. We're going to go ahead and plot the point 2, 1. I think I'm going to do is just go back here and get a new one. So I'm going to plot the point for number 26, which is 2, 1. So I go 2 on the x and 1 on the y, and there goes my point right there. And now it's asking us, it's telling us that the slope is equal to 4. And so if we think about rise over run, we can view the 4, the slope being 4, as 4 over 1. And so if I start off in point A at 1 on the y, I can go up 4. So it's going to go 1, 2, 3, 4. So I end up at the 5. And then I have to move over to the right 1. So the point will be point B. So let's look at it again. So they gave us the point 2, 1, which is this point, point A, and then they tell us that the slope is 4. So slope is rise over run, so I'm going to go up 4, and then to the right 1, since they're both positive. And so from 1, so I go to 2, that's 1, 3 is 2, 4, 3, and then 5 is 4, and then over to the right, and that gives me my second point, which ends up being 3, 5. And so if I turn around and I put graph these two, here I have the line that passes through the point 2, 1 and has a slope of 4. So what does that look like if I was doing this algebraically? Well, here, again, I'm going to label this as x1, y1. And so this equation becomes y minus 1 is equal to 4 times x minus 2. And then this would be the point slope form of the equation. Y minus 1 is equal to 4 times x minus 2. Now, the next thing that we're going to do, and which is not really asking us to do here, but we're going to finish this off so we can go ahead and find the final equation of the line that passes through 2, 1 and has a slope of 4. So here what we're going to do is we're going to distribute to 4, so it's 4x minus 8. And then I'm going to add 1 to both sides. So it becomes y is equal to 4x minus 7. And that's the equation of the line. So here's the point slope form, and then this is the slope intercept form. Now, I can arrive at this one simply by using the information that I was given. So if I view this, instead of being x1 and y1, simply just as an x and a y, if you notice here, the only thing that I'd be missing would be my b. So if I plug in the values that I have, so 1 is equal to 4 times 2 plus b. 1 is equal to 8 plus b, and then I subtract 8 from both sides. It's just a different way of you arriving at the answer. Then it's saying that my b, which is my y-intercept, is equal to negative 7. And if I go back and I plug it back into my equation, y is equal to 4x minus 7. It's the same answer that we got when we did it this way. All right, the next one is number 36. And number 36, it says the slope and a point on a line are given. Using information to locate 3 additional points in the line, and answers may vary. So what they're giving us for number 36 is a point, which is negative 3, 2, and then a slope. And it's asking us to find 3 additional points on the line. So I'm going to go back here to this one here. Let me get a new one. And so the first point that they gave us was negative 3, 2. So I'm going to go over to negative 3 on the x and up to 2. So that's the first point that I have. And then the slope is 4, 3. And so what I'm going to do then, since I have the point negative 3, 2, I'm going to go back over here. Since I have the point negative 3, 2, and my slope is 4, 3, and this is my rise over the run, then if I'm thinking about this as just movements or units, if you will, I'm going to go up 4, and then I'm going to go to the right 3 to get to my next point. And so, actually, let me do it this way so it's a little better. All right, so if I start off here with my point, and this could be my 3, 2, then this will be my second point, right? This point over here after going up 4 and over 3. And so if we think about that for a moment, if I start off here and I go up 4, so I'm going to go up 4, so that's 1, 2, 3, 4, right? So I'll be at 6 on the y, and then over 3, so I'd be 1, 2, oops, not that one. So I'm going to go from 2, so it's 1, 2, 3, 4, and then over 3. So 1, 2, 3, and that would be my second point. So my second point would be 0, 6. Now, let's see what that looks like here. So I'm going up 4 on my y, so if you think about it in this terms, this is going to be my next point, and that's going to be my other point, which will be the point what we got, which was 0, 6. And then just following this again, you know, if I repeat this process, so it's going to be 0 plus 3, and then 6 plus 4, I'm going to end up at 3, 10. So let's see what that looks like. I'm going to move this over here a little bit. So again, I'm going to go up 4 on the y. So I go from 6, so that's 1, 2, 3, 4. So I'm at the 10 on the y. And I'm going to go to the right 3 since they're both positive. So it's 1, 2, 3. And I'm going to end up with 10, 3. Now, I don't want to keep going up that way, so I'm going to kind of go here. But if you think about this, if I'm at 2 on the y, I can actually go down and to the left, right? Because a negative over negative is still positive. So 1, 2, 3, 4. So I'm at -2. And then I go over 3. So it's 1, 2, 3. Let me do this again. So I go 1, 2, 3, 4, and then 1, 2, 3. And if you notice, oops, no, that's not what I wanted. Okay, that's what I wanted. That's the line, and all 4 points, the 3 additional points, are on that line. So let me go back here. So since they're both positive, I can actually also do a negative over a negative, which would be a positive. So starting off at the original point, if I do -3, oh, I'll go back here. -3 and 2 minus 4, I end up at -6 minus 2. -6, -2, which is the last point, point E, that we ended up with. And so that's how you can actually use a slope to find additional points on the line. All right, let's go over to number 48. So number 48, here they're asking us to find an equation of a line with the given properties and express your answer either using the general form or the slope-intercept form of the line of the equation. So just a quick review. General form is ax plus by plus c, where a, b, and c are not equal to, where a and b are not equal to 0, and a, b, and c is actually equal to c, not plus c, are all integers. And so let's go ahead and use the point slope form. And so the point slope form is y minus y1 is equal to x, not x, m times x minus x1. Now using this information, we can do y minus -3 is equal to 2 times x minus 4. So a negative and a negative is a positive, so it's y plus 3 is equal to 2x minus 8. And then, of course, I'm going to subtract the 3 from both sides. And y is equal to 2x minus 15. And so the equation that we got for number 48 is y is equal to 2x minus 15. So this is the slope-intercept form. Now, we're going to go ahead and write it in the general form or the standard form. So remember, I need it to look like ax plus by is equal to c. And so if you notice for this one, all I have to do is just subtract the 2x from both sides, right? And so we're going to end up with negative 2x plus y is equal to negative 15. Now, we want the leading term to be positive, so we're going to multiply everything by -1. And so we end up with 2x minus y is equal to 15. So the two answers that you can have for this one, it's either y is equal to 2x minus 15 or 2x minus y is equal to 15. All right, let's look at number 62. And in number 62, they're asking us to find the equation that is parallel to y is equal to negative 3x and contains the point -1, 2. Now, in order for line 1 to be parallel to line 2, slope 1 has to be equal to slope 2. So the slope of line 1 has to be equal to the slope of line 2. And so what we're going to do here is we're going to use the slope from the line that was given to us. And in this example, the slope happens to be -3. And we're going to use the point -1, 2. So we've already done this in some of the previous examples. We're just going to go ahead and use the point slope to knock this thing out. So I'm going to label those. So y minus y1 is equal to m times x minus x1. So y minus 2 is equal to -3 times x minus -1. So y minus 2, and I'm just going to clean this up a little bit. right? And I'm going to go ahead and distribute the -3. And I'm going to add 2 to both sides. So -3 plus 2 is -1. So if we're going to write it in standard form, you can see that I'm going to have to add the 3x to both sides, right? If I add the 3x to both sides, I end up with 3x plus y is equal to -1. So this is your answer, or this is your answer. All right, so let's see number 68. Now this is perpendicular to the line that contains, to the line y is equal to 2x minus 3 that contains the point 1, -2. Now, in order for L1 to be perpendicular to L2, that means that the slope of line 1 times the slope of line 2 has to be equal to -1. In other words, they have to be opposite reciprocals. So looking at this line that they gave us, since it's in in slope-intercept form, the slope is equal to 2. So we're going to use this information to find the line that's perpendicular. Now, the opposite reciprocal, so this is M1. In this example, M1 is equal to 2. So then the slope of the line that I'm going to find has to be the opposite reciprocal of 2, because if I multiply 2 times this number, I need to get -1. And the only thing that's going to work is -1/2. If we think of 2 as being 2 over 1, the reciprocal of that is 1 over 2, and then we just change the sign. So the slope that I'm going to use is -1/2. So I'm going to go ahead and label these as x1, y1. So it's going to be y minus -2 is equal to -1/2 times x minus 1. So just cleaning it up a little bit, distributing it the -1/2, and then I'm just going to go ahead and subtract 2 from both sides. Oops. So I can go ahead and finish it off. So y is going to be equal to -1/2 x. Now, 1/2 minus 2 is going to be, since I need a 2 in the denominator, is going to be 4 over 2. And so that's going to be -3 over 2. So if I were to leave it this way, this would be the slope-intercept form. If I were to write it in standard form or the general form, it would have to look like ax plus by is equal to c. So again, like we did before, I'm going to add the 1/2 x to both sides. So I end up with 1/2 x plus y is equal to -3 over 2. But if you remember what I said before, in the standard form, a, b, and c all have to be integers. So I have to get rid of these fractions. And so I do that simply by multiplying both sides by 2, or everything by 2. So 2 times 1/2 is just 1, so that's my x, that's my 2y, and that's my -3. So these two underlying answers are your possible answers to number 68. All right, let's go down to number 79. And in number 79, what they're asking us to do is to find the slope and the y-intercept of each line. So there's two ways that we can do this. The first way is solving for y. Right? We're going to go ahead and solve for y. And so if I solve for y, the first thing I'm going to do in this particular example, let me go ahead and write it down over here, is I'm going to subtract x from both sides. So I get 2y is equal to 4 minus x. And then I'm going to divide everything by 2 because I want to solve for y, right? So it's going to be y is equal to 4 divided by 2 is 2 minus x over 2, right? So if I separate those fractions. So in this case here, if I were to just to rewrite this, right, this would be y is equal to negative x over 2 plus 2, which I can write as negative 1/2 x plus 2. So negative x divided by 2 is the same thing as negative 1/2 times x. So then my slope for this particular question is that my slope is negative 1/2, and then my y-intercept is 2. And if I were to write it as an ordered pair, it would be 0, 2. All right. And then the last one that we have is number 94. Now, number 94 says find the intercepts of the graph for each equation and graph the equation. So we're just going to go ahead and find the intercepts of each graph, and then we'll end it there. So if I'm finding the intercepts of each graph, what I want to do is I want to set x equal to 0 and solve for y. I want to make y equal to 0 and solve for x. So for the first one, if I make x 0, I get 3 times 0 minus 2y is equal to 6, which by virtue of setting x equal to 0, I eliminate that variable. And then here I'm just solving for y, and y is equal to negative 3. So then my y-intercept is 0, negative 3. Now to find my x-intercept, I do the same thing, but instead of the x, I go ahead and set my y equal to 0. You can see the process is fairly straightforward. So those are my two intercepts, 0, negative 3, and 2, 0. And so that's the end of the examples for 2.3. Thank you.